Hello everyone and a very warm welcome to all the viewers. As you all know that we are discussing your first topic in plant physiology, that is transport in plants. In my last video we discussed about some phenomena associated with plant water relation. Okay, we discussed about water potential, solute potential, pressure potential, and types of membrane. Okay, now in this section we will discuss other terms related with associated with plant water relation, and the first term in today's session is osmosis. The term given by knowledge, just learn it. What is osmosis? Osmosis is simply a diffusion process. Diffusion process. Diffusion of what? Water molecules, or diffusion of solvent. Diffusion of solvent through semi permeable membrane. In my last video I told you about semi permeable membrane that allow the passage of only solvent molecules through it, not any other molecule. Okay, so what is osmosis? How we will define the osmosis? It is defined as the passage of solvent molecules from a region of their higher concentration to the region of their lower concentration. Through a semi permeable membrane. This condition is must. Semi permeable membrane. Okay, let us take an example to understand osmosis. In this example, what do we do? Take a beaker, filled it with water, we can call it solvent. Okay, now take a funnel and tie a parchment membrane which act as a semi-permeable membrane on its wide mouth and put concentrated sugar solution in this funnel. Filled it with concentrated sugar solution, mark the level and put in upside down position in the beaker. Concentrated sugar solution. Okay. What will happen after some time? Again, I have to draw a beaker, that funnel, tie a membrane on its mouth. This is filled with sugar solution, concentrated sugar solution. Here is water. What will happen after some time? Because in the beaker there is pure water, it has high free energy, maximum free energy. And in funnel there is concentrated sugar solution, or we can say there is less number of water molecules comparison to the outside. So water will start move inside the funnel through this membrane. From this side it will start move inside the funnel, and the level of sugar solution rises in the funnel. Okay. कब तक? Up to what time the entry will continue? जब तक कि concentration of water molecule becomes equal outside or inside. Outside and inside. After that what will happen? The movement of water molecules comes in dynamic state of equilibrium. Means जितने molecules बाहर से अंदर जाएंगे उतने ही अंदर से बाहर आ जाएंगे. तो no net movement क्या हो जाएगा? Zero हो जाएगा. And the level of sugar solution becomes stable. It will not increase at that time. So this is simple osmosis. Again, how will I define it? It is the passage of solvent molecule from their higher concentration towards their lower concentration through a semi-permeable membrane. Okay. I hope clear हुआ होगा आपको what is osmosis. Now there is another term related with osmosis, that is osmotic pressure. What is osmotic pressure? Okay. So to define the osmotic pressure, take the above example as I discuss here. Again, the beaker filled with water, the funnel filled with the concentrated sugar solution and tied with a parchment membrane or the semi-permeable membrane on its mouth, and put it in upside down position into the beaker. So now इससे पहले कि water अंदर जाना शुरू करे, it starts moving inside, we put a piston here and apply a pressure in this direction so that the water molecules entry should be stopped. Okay, water molecule की entry stop हो जाए. हमें इतना pressure लगाना है कि एक भी water molecule यहाँ पर enter ना करे. तो ये जो pressure, the pressure we are applying here, that pressure is called osmotic pressure. This is osmotic pressure. Okay. How will we define the osmotic pressure? Pressure needed to prevent the entry of water molecule into the solution through semi-permeable membrane. That pressure is called osmotic pressure. Okay, and second definition is also we can define as it maximum pressure which develop in an osmotically active solution when it is separated by pure solvent separated from pure solvent by a semi permeable membrane. Clear? If we talk about the numerical value of osmotic pressure, then osmotic pressure or OP, in short we write down it OP. OP is always equals to the osmotic potential, or we can call it solute potential. I discussed it earlier, and its value is always negative. Its value is always negative. Okay? Osmotic pressure की value always negative होती है, and it is always equal to the solute potential. The concentration of solute molecule in the solution. We will define how much osmotic pressure is required to prevent the entry of water molecule. Yeah. Okay, now we will discuss the factors affecting osmotic pressure. Factors affecting osmotic pressure. The first one is concentration of solute particle. As I told you earlier, more the concentration of solute particle in any solution, more will be the osmotic pressure, because it requires more water to its free energy is less than pure solvent, always less than pure solvent. More the concentration of solute particle, more will be the osmotic pressure. Second one is ionization of solute. What will happen if you put a solute in a pure solvent, and solute जो होता है वो ionize हो जा रहा है. If we talk about in molecular term, तो एक molecule के दो molecule हो जा रहे हैं, means concentration of solute particles increases after ionization. So again the same case as I told you earlier, more the ionization of solute, what will happen? It will increase the number of solute particle or concentration increases. What will happen? Osmotic pressure increases. Third one is hydration. What is hydration? If any solute particle, when put in pure solvent, wait a minute. When solute is added with solvent, it gives solution. But in solution, what will happen? The solute particle absorbs some water on its surface. This is called hydration. Absorption of water on the surface of solute particle. So what will happen? Number of free water molecule decreases or concentration increases, and concentration increases means more osmotic pressure. So more the hydration, more will be the osmotic pressure of any solution. And last is temperature. How will it affect the osmotic pressure? When we heat up the solvent or heat up the solution, then the heat will increase the free energy of water molecule, and heat also increases the permeability of the membrane. Okay, then both of these condition क्या करेंगी ये मिल करके? It will increase the osmotic pressure of any solution. क्योंकि वाटर की फ्री एनर्जी इंक्रीज हो गई, मूवमेंट ज़्यादा होगा, मेम्ब्रेन की परमेबिलिटी इंक्रीज होगी, तो मोर वाटर विल नाउ एंटर इनटू द सॉल्यूशन थ्रू द मेम्ब्रेन, so osmotic pressure will increase. Now here are the four factors which affect the osmotic pressure of any solution. Now आगे बढ़ने से पहले एक टर्म है जो यहाँ पर बतानी है, that is type of solutions. Type of solutions. Actually we will discuss it with respect to the cell cytoplasm. Type of solution with respect to cell cytoplasm. अगर हम साइटोप्लाज्म की कंसंट्रेशन देखें और उससे कंपेयर करें तो हमारे पास तीन टाइप के सॉल्यूशंस होते हैं. फर्स्ट वन इज हाइपरटोनिक, देन इज हाइपोटोनिक, एंड देन इज आइसोटोनिक. What are hypertonic solutions? Hyper means more. तो ऐसा सॉल्यूशन जिसकी कंसंट्रेशन सेल साइटोप्लाज्म के कंपैरिजन में ज्यादा है, that solution is called hypertonic solution. Okay, for example, a cell placed in sugar solution. तो शुगर सॉल्यूशन क्या है? कंसंट्रेटेड, और वी कैन से हाइपरटोनिक. ओके, और सेल साइटोप्लाज्म क्या है? हाइपो, we call it hypotonic. Hypo means कम, लेस. ओके, तो साइटोप्लाज्म की कंसंट्रेशन क्या है? कम. शुगर की कंसंट्रेशन क्या है? ज्यादा. तो one solution is hypotonic and another is hypertonic. What does it mean? Hypotonic means हो गया it contain more water molecules. It contain less water molecules. तो इसकी वाटर पोटेंशियल ज़्यादा है, इसकी सिस्टम की एनर्जी ज़्यादा है, इसका वाटर पोटेंशियल कम है, इसकी एनर्जी कम है. वाटर विल मूव फ्रॉम सेल टू आउटसाइड. सेल क्या होगी? श्रिंक कर जाएगी क्योंकि सेल से वाटर बाहर निकल गया. So what is hypertonic solution? Hypertonic solutions are those solutions whose concentration is more in comparison to the cell cytoplasm. And when we place a cell in hypertonic solution, water will move out from the cell. Water will exit from the cell, and this process is called exosmosis. Exit. of water from cell. Okay, clear? दूसरे होते हैं, आई टोल्ड यू हाइपोटोनिक सोल्यूशन, अभी बताया मैंने हाइपोटोनिक सोल्यूशन. Hypotonic solutions, for example, put a cell in pure water. This is water. This is cell. What will happen? Water is what? Water की concentration cytoplasm के concentration के comparison में कुछ भी नहीं है, nothing. It is dilute, है ना? और hypotonic. जबकि cell cytoplasm क्या है? Hypertonic. Now, so now here the energy of water molecule is more or solvent is more, and energy in the inside the cell is less, water potential is less, water will start moving inside the cell and cells swells up. Okay. For example, raisins. Raisins को अगर आप water में रख दें, what will happen after some time? Raisin swells up. Clear? Now next is isotonic solution. Isotonic solution, iso means equal. So this solution whose concentration is just equal to the cell cytoplasm, they are called isotonic solution. The concentration of solvent is equal to the concentration of cell cytoplasm. तो वाटर का जो मूवमेंट है, वाटर तो दोनों तरफ अवेलेबल है, क्या होगा? इक्विलिब्रियम. ठीक है. Neither cell swells up nor shrink. Clear? When we put a cell in isotonic solution, net flow of water is zero. We can say that the water now is in dynamic state of equilibrium. जितने वाटर मॉलिक्यूल बाहर से अंदर जाएंगे उतने ही अंदर से बाहर आ जाएंगे. सो नेट मूवमेंट जीरो हो गया, तो सेल नाइदर स्वेल्स अप नॉर श्रिंक. So these are three type of solutions with respect to the cell cytoplasm: hypertonic, hypotonic and isotonic solution. Okay, one more thing is here कि यहाँ पर सेल स्वेल कर रही है ना, वाटर सेल के अंदर एंटर कर रहा है. इन केस ऑफ हाइपोटोनिक सोल्यूशन, when we place a cell in hypotonic solution, this process is called endosmosis. Endosmosis, entry of water in cell. Okay, just learn it. Endosmosis and exosmosis, two type of osmosis are there, endosmosis and exosmosis. I hope it will be clear to you all. Now come to the next topic, Turgor pressure. पहले भी डिस्कस किया है हमने. Turgor pressure. What is Turgor pressure? When we placed a cell in hypotonic solution, what will happen? Water moves from outside to inside of cell. आई होप ये दोबारा बताने की जरूरत नहीं है कि ऐसा क्यों हो रहा है. हाइपोटोनिक सोल्यूशन है ना, इसका एनर्जी ज़्यादा है, सेल के अंदर साइटोप्लाज्म कंसंट्रेटेड है. व्हाट विल हैपन? सेल स्वेल्स अप. ओके, जस्ट एक रेजिन ले लीजिए, है ना, पुट इट इन अ beaker filled with water. So after some time it swells up. Okay, because of endosmosis. ठीक है. My question is, ये जो water अंदर enter किया inside the cell, what will happen? ये water जो है ये सेल की वॉल पे एक प्रेशर लगाता है बाहर की तरफ. That pressure is called Turger pressure. How we will define it? Plant cell absorb water, become turgid, है ना, due to entry of water molecules. This entry of water molecules develop pressure on the cell wall towards किस direction में? Towards outer side. Means if this is the cell, water आया तो water इस तरफ pressure लगाएगा ये. That pressure is called Turger pressure. Clear? But कितना प्रेशर लगेगा? अगर ज़्यादा वाटर मॉलिक्यूल अंदर एंटर किए तो सेल तो बर्स्ट हो जाएगी एक लेवल पे आकर. जब अंदर का प्रेशर बाहर के प्रेशर से एक्सीड करेगा सेल विल बर्स्ट. बट ऐसा होता नहीं है. व्हाई? बिकॉज देयर इज अनदर प्रेशर कॉल्ड वॉल प्रेशर. व्हाट इज वॉल प्रेशर? when a cell this is cell wall, this is nucleus. तो वाटर इस डायरेक्शन में प्रेशर लगा रहा है, इट इज टर्गर प्रेशर. तो वॉल इधर को प्रेशर लगाती है इन ऑपोजिट डायरेक्शन. दिस इज वॉल प्रेशर. ओके, हाउ विल वी डिफाइन इट? सेल वॉल develop equal and opposite pressure towards cytoplasm. That pressure is called wall pressure. And for fully turgid cell, Turger pressure is always equal to wall pressure. And numerically both Turger pressure and wall pressure has positive value. Except for Turger pressure, it is negative in flaccid cell and xylem vessels. पहले भी बताया है मैंने. I will discuss it in the mechanism. क्या इसके बेनिफिट होते हैं, क्यों ये नेगेटिव होता है. ओके, तो क्लियर हो गया व्हाट इज टर्गर प्रेशर, व्हाट इज वॉल प्रेशर. ठीक है. नाउ द नेक्स्ट टर्म इज in plant water relation, the next term is diffusion pressure deficit. Diffusion pressure deficit, or we can call it DPD. सबसे पहले डिस्कस करेंगे व्हाट इज डिफ्यूजन प्रेशर. डिफ्यूजन प्रेशर इज द एबिलिटी of the molecule or ion of any substance to diffuse from an area of their higher concentration, their higher concentration to an area of their lower concentration. Okay, what is diffusion pressure? The ability of the molecules or ions to move from the area of its higher concentration towards the area of their lower concentration. For pure water, it is just parallel to the water potential. For pure water, diffusion pressure is maximum. For solution, what will happen? Diffusion pressure is less than pure water, always. So there is a different. Deficit means what? What does it mean? Deficit. Deficit means deficiency or decrease. Okay. So diffusion pressure deficit means deficiency or decrease in the diffusion pressure, difference in the diffusion pressure. Okay. तो यहाँ पर आप देखो प्योर वाटर का मैक्सिमम है, सोल्यूशन का लेसर है, ऑलवेज नेगेटिव होगा. ओके. तो दिस डिफरेंस ऑफ डिफ्यूजन प्रेशर, this difference of diffusion pressure allow water to move from pure water towards the solution. Hence, DPD is also called suction pressure. Suction pressure. It drags the water towards itself. Because of this DPD, water drags towards the concentrated solution. Okay. Its value, DPD की जो numerical value होती है, it is always positive. DPD is always positive. Numerically, अगर if I want to conclude what is DPD, then DPD is equals to osmotic pressure minus turgor pressure. Just recall the water potential. This equation resembles with the water potential equation. Osmotic pressure or osmotic potential क्या होता है? Solute potential. The more the concentrated is the solution, more will be the, less will be the what? Diffusion pressure. Okay. Less will be the diffusion pressure, less water molecule present in the solution. Okay. What will happen? Turgor pressure, number of water molecule present in the cell. More the water molecule, more will be the turgor pressure. So these two terms define the diffusion pressure deficit. And there are three conditions. Regarding this equation. Told you. I told you DPD is equals to OP, osmotic pressure minus turgor pressure. First situation, for fully flaccid cell. What is a flaccid cell? Just imagine no water inside the cell, shrinked shell. Okay, you can call it shrinked cell. So in this case, turgor pressure is value क्या हो जाएगी? 0. क्योंकि वाटर है ही नहीं. वाटर जब है ही नहीं तो वो क्या वॉल पे प्रेशर लगाएगा? है ना. तो tugger pressure becomes 0, and in that case DPD will be equal to the osmotic pressure of the solution. ओके. दूसरी सिचुएशन है, water will start entering inside the cell. What will happen? Entry of water molecule into the cell causes development of tugger pressure. Now tugger pressure increases as time pass. ओके. बट कब तक? एक लेवल आएगा जब ये टगर प्रेशर जो है इसके ऑस्मोटिक प्रेशर के बराबर हो जाएगा. व्हेन tugger pressure becomes equal to osmotic pressure, then what will happen? DPD, we know that DPD is equals to osmotic pressure minus tugger pressure. tugger pressure को मैं osmotic pressure के टर्म्स में लिख सकती हूँ और it will become 0, यानी कि DPD becomes 0. What does it mean? Entry of water molecule stop into the cell. Is it really so? Stop हो जाएगी? Again, I am telling you, I am saying ये स्टॉप नहीं होगी, इक्विलिब्रियम में आ जाएगी. जितने वाटर मॉलिक्यूल अंदर जाएंगे उतने ही बाहर आ जाएंगे, एंड नेट फ्लो ऑफ वाटर मॉलिक्यूल 0. Clear? So this is all about the diffusion pressure deficit, how it works, and it drags the water molecules towards the concentrated solution. Clear? Now, the last topic in this section is imbibition. What is imbibition? Just I discussed it earlier. Adsorption of solvent on the surface of solute particle. होगा क्या? solute particle swells up. This is imbibition, है ना. इसका यूज क्या है? हमारे जो प्री हिस्टोरिक मैन थे, नहीं, इसका यूज आपका इसका एग्जाम्पल है इन रेनी सीजन wooden doors swells up by absorbing moisture. Absorbing and absorbing, both processes will take place simultaneously. Absorbing moisture is what? Water. ओके. ये आप सबने देखा है रेनी सीजन में हमारे जो वुडन डोर्स होते हैं वो कितने टाइट हो जाते हैं, उनको ओपन करने के लिए या क्लोज करने के लिए हमें फोर्स लगाना पड़ता है. और इस प्रोसेस का यूज हमारे प्री हिस्टोरिक मैन किया करते थे स्टोन्स, बड़े बड़े स्टोन्स को कट करने के लिए. Prehistoric mans used dry wood to split rocks. क्या करते थे वो? रॉक्स में कोई क्रेक दिखा, क्रेक में उन्होंने वुडन ब्लॉक को फंसा दिया और उसमें पानी डाला. पानी डालने से वुडन ब्लॉक क्या हुआ? स्वेल कर गया. स्वेल होने से क्या हुआ? क्रेक धीरे धीरे बड़ा होता जाता था और अल्टीमेटली क्या होता था, जो स्टोन रॉक होती थी या जो स्टोन होता था वो स्प्लिट हो जाता था. ठीक है. अगर हम लिविंग सिस्टम में देखें तो इम्बाइबेशन का कहाँ यूज है? जब सीड जर्मिनेशन होता है, ड्यूरिंग सीड जर्मिनेशन. जो सीड कोट होते हैं ना, absorb water. Swells up, open, open up, and radicle and plumule comes out. Develop a baby plant. Without this process, the radicle and the plumule will not come out, or there will be some resistance. Okay. तो इम्बाइबेशन का ये यूज है हमारे बायोलॉजिकल सिस्टम में, और आप ट्रांसपोर्टेशन में भी पढ़ोगे आगे जब मैं पूरा मैकेनिज्म आपको समझाऊंगी. देन आई विल टोल्ड यू कि कहाँ इम्बाइबेशन यूज होता है और कैसे ये हेल्प करता है वाटर के ट्रांसपोर्टेशन में. सो दिस इज ऑल डन फॉर टुडे. आई होप कि आप लोगों को समझ आया होगा. इफ यू हैव एनी क्वेरी, राइट डाउन इट इन द कमेंट सेक्शन. आई विल definitely discuss it with you all. In next lecture, I will discuss some questions regarding all the phenomena we have discussed till now in all my 3 videos. Okay, so be prepared for that, and till then, stay safe, stay healthy, keep studying. Goodbye.